This request is valid. GraphQL. The caller is authenticated. The schema accepts every field, and the server just returned 5 private reports when this user owns only 1. The request uses 5 aliases, so one document asks for 5 report IDs. The resolver checks that the token is valid, loads each report, and returns it. What it never checks is whether the current user may read that specific report. This is not a public target. It is an intentionally vulnerable local fixture with invented organizations, users, reports, and tokens. But the failure shows why a green GraphQL response proves very little. Schema validation tells us that a query is structurally allowed. Authentication tells us who the caller is. Neither one proves object authorization, field authorization, mutation permission, safe input handling, or bounded backend cost. In this video, we will run 10 defensive tests against CedarDesk Graph. We will use the same owned fixture to show the failure, apply the control at the owning boundary, and capture evidence that can run again before every release. GraphQL has several layers, and they answer different questions. Parsing asks whether the document is syntactically valid. Validation asks whether fields, arguments, fragments, and types match the schema. Authentication establishes an identity. Authorization decides whether that identity may perform this action on this object and field. Demand control decides whether the requested work fits an acceptable budget. Execution runs resolvers. Audit records what happened. If we collapse those layers, we get common false assurances. The endpoint requires a token, does not prove tenant isolation. The schema rejects unknown fields, does not bound list sizes. We disabled introspection does not remove a hidden authorization bug. We rate limit requests does not stop one request from carrying hundreds of aliases or multiple batched operations. Our test suite will therefore score outcomes, not settings. For every operation, we need to know which identity acted, which objects and fields were requested, which policy allowed or denied them, how much work the operation could trigger, what external response was returned, and what internal evidence remains. CedarDesk Graph is a local reporting application. Organization Blue owns reports 1 and 2. Organization Amber owns reports 3 through 5. Alice is a Blue member. Morgan is a Blue administrator. Casey belongs to Amber. The schema exposes direct report lookup, a global node field, organization relationships, search, report export, and mutations that approve or archive a report. It also exposes a public product catalog so we can distinguish public data from private data. Every resolver uses a fake in-memory adapter. No real database or network exists. Each operation has a deterministic cost: object lookup, list item, relationship traversal, search call, and export all add known units. Before running the server, we lock the answer key. It records which identities may access each object, field, edge, and mutation. Maximum legitimate list sizes. Accepted structural measurements. Expected cost. Expected external error and required internal audit event. We keep vulnerable and corrected configurations side by side. The point is not to teach one framework switch. The point is to prove the same security outcomes regardless of which GraphQL library, router, or gateway a project uses. Test 1 asks a basic question that many teams cannot answer. What GraphQL surface is actually deployed? Inventory. Every endpoint and transport. Include HTTP post, HTTP GET. If enabled, WebSocket subscriptions, multi-part upload paths, gateways, routers, subgraphs, development IDEs, schema downloads, health routes, and alternate host names. Then inventory the schema by operation type. Which root queries expose IDs, global nodes, search, exports, or admin data? Which mutations change money, permissions, publication state, or external systems? Which fields reveal sensitive relationships? Introspection is one part of this map. Some systems intentionally expose it. Others restrict it in production. Disabling introspection may reduce easy schema discovery, but it does not remove fields, protect resolvers, or authorize objects. So score the actual exposure decision, not a universal on-or-off rule. The pass condition is an owned production surface manifest tied to the deployed build. A failure is an undocumented endpoint, an IDE left open accidentally, a mutation reachable through an unexpected gateway, or a schema whose sensitive fields have no named owner. You cannot secure a boundary that the team has not enumerated. Test 2 enforces object authorization on every lookup path. Alice may read report 1, she may not read report 3. That decision must remain true whether she supplies the ID to report, looks it up through node, reaches it through an organization relationship, finds it through search, requests it under an alias, or includes it in a batch. Run the same object policy case across every equivalent path. If one resolver checks organization ownership and another shared loader returns by raw ID, the boundary is inconsistent. Test 3 covers fields and edges. Alice may read a report title but not an internal risk score. She may see the report's public owner name but not private billing details. An organization administrator may traverse a member's edge. A normal member may not. Do not put these checks only in the UI or root query. Authorization must survive nested traversal and shared loaders. Also verify that caching and batching do not reuse an object authorized for one caller in another caller's context. The evidence matrix records the path, identity, object, field set, policy decision, and returned shape. One deny rule across 6 paths is stronger evidence than one happy path test on one resolver. Queries read state. Mutations change it, sometimes with external side effects. Test 4 checks. 4 dimensions for every sensitive mutation. Who the caller is, which object they target, whether the current state permits the transition, and which side effects the operation may trigger. In CedarDesk, Morgan can approve a blue report in draft. Alice cannot. Morgan also cannot approve an amber report, even though the role name is admin. And no one can approve a report that is already archived. The vulnerable resolver checks only the role. The corrected boundary loads the target, confirms organization ownership, validates the current state, records the transition, and then invokes the fake side effect exactly once. Also test partial failure. If the state change succeeds but a notification fails, a retry must not repeat the transition or trigger a second external action. The GraphQL mutation name is not the authorization policy. The owning business service must decide whether this identity can perform this transition on this resource now. A mutation that returns an error after changing state is still a changed system. Capture both the response and the committed result. GraphQL validates types, but a valid string can still be too long, unsafe for a downstream query, or meaningless for the business. Test 5 covers every argument that reaches a resolver or downstream adapter. Use enums for close choices. Bound string length and normalize identifiers. Validate dates, ranges, pagination cursors, file references, URLs, sorting fields, and filter operators. Reject unknown or contradictory combinations before they reach SQL, search, HTTP, file, or command adapters. The fixture includes a search filter with a valid GraphQL string that attempts to select an unsupported internal field. Another case supplies a huge regular expression-like pattern to the fake search adapter. A third uses a syntactically valid ID from the wrong object type. The corrected resolver converts raw input into a small validated command. The adapter never receives the original unbounded structure. Do not claim GraphQL prevents injection automatically. It helps define a typed contract, but application code still decides how values are interpreted downstream. The evidence export records validation outcome and a redacted adapter call. We prove that rejected input never reached the sink, not merely that the client received an error. Lists multiply work. A field that returns 10 organizations may resolve 50 reports, and each report may resolve comments, owners, attachments, and permissions. A shallow query can still create enormous fanout. Test 6 sets explicit bounds for list arguments and default sizes. It verifies cursor behavior, maximum page size, total response size, and the number of downstream calls caused by one page. Do not treat pagination as a UI feature. It is a resource boundary. A missing first argument should not mean return everything. An absurd amount should fail before allocation or adapter work. Also test nested lists. 10 organizations times 50 reports is 500 report nodes before deeper fields. The structure analyzer should estimate that multiplication rather than looking only at depth. Choose limits from legitimate operations and backend capacity. Example values in documentation are starting points, not production policy. The pass condition includes proof that oversized requests are rejected or safely clamped according to the documented contract. Resolver calls remain within budget, and clients receive a stable error they can handle. Test 7 measures the document before expensive resolver work begins. Depth captures the deepest nested selection. Height captures the number of unique field coordinates. Alias count catches one document that repeats the same expensive field under many names. Root field count catches wide operations. Token and parser recursion limits protect the parser itself. The opening 5 report request is shallow. A depth limit alone would not stop it. That is why we measure several dimensions. Build legitimate operations from the current application and measure them in a warning mode first. Then set enforced limits with margin for real clients, document the rollout, and keep an explicit exception process. Fragments require careful analysis. Repeated fragments and inline fragments can hide width or depth. The analyzer must operate on the validated document the server will execute, not on a naive text pattern. When a request exceeds a limit, reject it before resolver execution and record the measured value, configured maximum, client identity, and operation hash. Do not log sensitive variable contents just to explain the rejection. Structural limits reduce one class of abuse. They do not replace object authorization or business-aware cost analysis. Counting HTTP requests is not enough. GraphQL can batch multiple operations in one transport request. One operation can repeat fields with aliases. One resolver can be cheap while another triggers an expensive export or search. Test 8 charges. The caller for business work. Assign deterministic cost of fields and list items in the fixture. Compare predicted cost before execution with actual resolver work after execution. Reject operations over budget, cancel resolvers after the defined timeout, and apply rate limits per authenticated identity and relevant resource, not only by IP. Then test combinations. 10 individually acceptable operations may exceed a batch budget. A shallow query may call one expensive export resolver. A shared IP may contain many legitimate users, while one user may rotate IPs. Start by measuring real legitimate operations. Move to enforcement only after the team understands false positives, client behavior, and capacity. A warning configuration is not active protection, so the release evidence must show the deployed enforcement mode. The pass condition is bounded work with deterministic rejection, resolver cancellation evidence, and metrics that reveal who consumed the budget and why. Test 9 checks. Production errors and tools. External responses should not expose stack traces, database details, internal host names, source paths, or sensitive variables. Internal logs still need enough context to diagnose the failure. Compare both sides. Review introspection, IDEs, schema suggestions, debug modes, and alternate endpoints according to the product's threat model. Restricting them can reduce unnecessary exposure, but none of these settings fixes a resolver that returns the wrong object. Test 10 checks operational evidence and trusted operations. For first-party clients, registered or trusted documents can reduce arbitrary query surface. The registry should track document hash, owner, version, rollout status, and removal path. Public or third-party APIs may need a different model. Trusted documents are not authorization. An approved document can still request report ID 3 for Alice, unless the resolver checks the object. Keep release tests for every object path, mutation transition, structural boundary, cost rule, and error mapping. Monitor rejected operations, cost distributions, timeouts, USUS authorization denials, and schema drift without logging raw secrets or private response data. The final evidence ties the running build to the manifest and configuration. Source code intent is not enough if production runs a different router mode. Now, make a release decision. Block. If any path returns an object or field across the authorization boundary, a mutation changes an unauthorized resource, untrusted input reaches an unsafe sync, a list or operation can trigger unbounded work, duplicate execution repeats a state change or production error, responses leak sensitive internals, limited rollout. If authorization blockers pass but limits, trusted operation coverage, client compatibility, monitoring, or capacity data still need refinement. Keep the endpoint behind a small client set, enforce conservative budgets, and review rejection evidence. Ship for the defined surface. Only when the deployed manifest is current, equivalent paths produce the same policy decision, mutations enforce business state, inputs are bounded, lists and structure stay within measured limits, cost controls are enforced, errors are safe, and the evidence suite can replay in CI and staging. This does not prove the GraphQL API is secure forever. Schemas, resolvers, clients, and traffic change. The package proves that one deployed surface met one documented test at one point in time. Run these 10 tests against the deployed schema before the next release. And tell me which boundary should get the next owned fixture. Webhooks, file uploads, SSRF, multi-tenant search, or background jobs.